Hi guys, a very good evening everyone. Welcome all of you to your wonderful and your favorite platform for preparation of GATE Engineering Services, PSUs and all technical based examinations, state level examinations, and the best one for EC and EE, that is the OHM Institute. Yes guys, I Rakesh Sir, I welcome all of you to this session, and from past few days we have been learning some important concepts for your GATE and Engineering Services preparation. Okay, whether preparing for 2025 or 2026, and we will be having many more concept based sessions and also other guidance sessions on this YouTube channel. So always be subscribed to our YouTube channel so that you attend and you are notified about all these sessions. So last class, we studied Monday about the continuous time periodic signal. So periodic signals, again an important concept from signal and system, and I split it into continuous separate and discrete separate. The reason is simple, because the basic idea of periodicity remains to be same. Okay, but due to the discrete nature of the time, where time can only take integral values in the discrete time domain, there are some fundamental differences when in terms to computations, when it comes to methods between the continuous time periodic signals and the discrete time periodic signals. Very good evening everyone. Keep joining the session. Update all your friends also that the session is now live. Good evening Ganesh, good evening Ramji Patel. Yes guys, and then let's get started quickly. Okay dear. Yes, I think at my end audio video looks good. You can also confirm me. Good evening Shiva. You can also confirm me if the audio video is fine. Yes everybody. I think at my end audio video looks good. You can also confirm me. Good evening Shiva. Okay. Yes, good evening Swapna. All right. Chalo. So if all good at your end also, let's get started. All clear? Okay, great. So discrete time periodic signals. This is a brief intro. If in some case somebody new to my sessions, you can have a look into it. Now guys, as I told you, the basic idea of periodicity is going to remain as same. Okay, that we already discussed in the last class, that if the value or the nature of a signal after certain fixed amount of time keeps repeating from minus infinity to the plus infinity, then such a case will be known as a periodic signal. Now here it's a case of a discrete time periodic signal where this is the origin n equal to 0, and let's say I'll just write down some values here. Maybe this value is 2, this is 1 1, this is 2 1 1, and etc. Okay, that means the given signal xn, if you want to express in the form of sequence, okay, in the form of sequence, okay, runs from minus infinity, and then there are some samples 2 1 1, 2 1 1, let's say this is the origin, okay, 2 1 1, 2 1 1, these particular set of values would be repeating till infinity, okay. Then okay, the minimum possible value of time after which repetition occurs is of course the time period, okay, is of course the fundamental period here, and that is n equal to how much? 3. This is 1 2, and of course this turns out to be 3. Okay, so here the repetition is after every 3 units of time. Also, as we discussed in the last class, if the value of the signal repeats after 3 units, it is again repeating at 6 units. This is 4, 5, 6. It is again repeating at 9 units of time, and etc. If the value of a signal repeats after n, it will repeat at 2n, it will repeat at 3n, it will repeat after every integral multiple of n, right? So if I normally say period, as we discussed in the last session as well, okay, if you say period could be n, 2n, 3n, 4n. Of course, logically, by default, we talk about n, okay, the minimum value of time, and that is specified clearly by writing fundamental period. Okay, although normally textbook would also take the fundamental period as by default the period only, but I will separately specify here fundamental period is that smallest value of time after repetition occurs. Okay, in general period could be n, 2n, 3n, 4n, etc. If the value of the signal repeats at n, it repeats after every integral multiple of the time period, right? Chalo, that smallest time period is the n here, which is in this example equal to 3. Okay, or it could be following a particular pattern as well, like you see a particular ramp. If you join this discrete domain, okay, suppose if it was continuous, if you join these dots, okay, linearly, okay, this is what is a ramp, okay, a particular ramp from -5 to 5, and then it keeps on repeating, a straight line keeps on repeating. Okay, so this is again a periodic signal with what period? Now again, for the period I told you, okay, you can take any two similar points and take the distance between them. Okay, so for example, I take the center. So if this is the line you consider, this is the center of the line. Okay, and then this is the next line you consider, and this is going to be the center of the line. So if I have the center to center mapping, okay, if I take it from the center to center mapping, okay, this is 0 and this repeats at 10. Okay, this is actually 10. Okay, this repeats at how much? This repeats at 10, right? This repeats at 10. So 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, that is 11 only, sorry. 6, 7, 8, 9, 10, this is 11. So the time period here is 11. The time period here is 11. Clear, everybody? Or you can, as I told you, you can measure it, either from the center to center, or, if somebody wants, they can measure it from this point to that point as well. Okay. What? From the highest peak point, or from this minima point, from this point to this point, it's going to be 11 everywhere only. It's not going to be a difference anyways. It's not going to be a difference anyways. Clear, everybody? Okay. Now, moving ahead to the next, okay, the very, very important point, what we learned in continuous time domain, and we will, compare also with the results of continuous time domain. In continuous time domain, we learned that A sin omega n or A cos omega n is always and always periodic. A sin omega t, sorry, in continuous time domain, A sin omega t, A cos omega t is always and always periodic. What happens here? Okay, what happens here? Okay, just a moment. Okay. After I teach you the addition also, let me start making a table here. Okay, let us start comparing here continuous time and discrete time. Okay, the continuous time and the discrete time. The first basic results that you have to consider is in continuous time, whenever you consider A cos omega t or A sin omega t, the basic sinusoids, okay, they are always periodic, isn't it? They are always periodic. Okay, with how much period? With period. Okay, period means fundamental period 2 pi by omega, where omega is the fundamental frequency. That is what we know. They are always periodic. Okay. What happens in discrete time? Whether again do you get periodicity always, or is there some twist? Okay, so this is the waveform of a sinusoid signal, okay, which definitely looks periodic here. Okay, but will it be always periodic for any value of omega? Okay, let's have a look into this. Okay, so dt periodic signals, considering any one of them, suppose I take xn is equal to A sin omega n, and suppose this is periodic. Okay, suppose this is periodic. So if it is periodic, okay, it should follow x of n plus n equal to n. Okay, the value of the signal after every n, capital N units of time should be the same. That is what we know. Okay, the x of n plus n should be equal to x of n. Now what is x of n plus n? A sin of omega, n is replaced by n plus n. Okay, should be equal to A sin of omega n. Okay, so A sin of omega n plus capital omega capital N is equal to A sin omega n. Okay, now call this as theta. Okay, so sin theta plus something equal to theta. Sin theta plus something equal to theta. Okay, sin theta plus something equal to theta. That is only possible if that is 2 pi, because sin theta value repeats after 2 pi. So this much part is also the same. So this particular part, omega n, should be equal to 2 pi. Should be equal to 2 pi. Clear? So here again we get that n equal to 2 pi by omega. n equal to 2 pi by omega. But ये calculation तो simple है, but there is a twist. Okay, we again get the same formula that it should be periodic, you know, if the period is 2 pi by omega. Okay, because omega into n will become 2 pi, but there is a small twist here. What is the twist? Let's understand. What is the twist? Let us understand. Okay, suppose if I write down xn is equal to, okay, 2 sine of, you know, suppose 4n. So then we can say that this should be periodic with how much period? Okay, with the period. Okay, what is the omega here? The frequency is 4. So what should be the period? 2 pi by omega, and that leads to the answer 2 pi by 4 or pi by 2. Okay, or pi by 2. Okay, or it should be equal to the pi by 2. Now pi, now what is the time period here? Pi by 2. Okay, 3.14 by 2. 3.14 divided by 2. Will it be an integer? We should be very well aware that in discrete time domain, the time can only take integral values of time. Okay, whether you take n or whether you take n plus n, whatever come inside this bracket, whatever is the argument, whatever is the value of time, it should be always purely an integer, maybe positive or negative integer, but it has to be integer. Okay, that is what we all know. Clear? That is what we all know. So here necessarily integer should come, and for this to be integer, okay, this condition is not satisfying. N equal to pi by 2, it is not an integer. It is not an integer. Okay, and hence this particular class of signal, okay, it is aperiodic. It cannot be periodic. Okay, for it to be periodic, there must be time period, and the time period coming as per the calculation here is non-integer, which is not allowed here. The only possible value coming here is non-integer, pi by 2. It is not periodic here. Okay, let's have a look into a different case. Okay, let's take 2-3 cases to understand this problem. Okay, now suppose, now whatever, you know, calculations I am doing for sine, applicable for cos also, vice versa. Okay, suppose you have the signal. Okay, dear, now understand. Suppose you have the signal sine pi n. Okay, now, okay, what is the omega that I have taken? Now, what is the omega that you have taken? Omega equal to pi. Okay, so what can be the period now? 2 pi by omega, that is 2 pi upon pi, and that becomes clearly 2. It's a perfect integer. It's a perfect integer, and hence, yes, this is a valid period, and hence the given signal is periodic. The given signal is periodic. With how much period? With the period equal to 2. Okay, with the period equal to 2. This one is periodic, no doubt. Okay, I can clearly say this one is periodic with the period equal to 2. Okay, next case. Okay, let's take one more slide here. Let's take one more case here to conclude on important things. Okay. Yeah. So next case. What is the next case? Now let me take xn is equal to 3 cos 3 pi n. 3 cos 3 pi n. So what is the omega taken here? Okay, the omega taken here is 3 pi. Okay, so what is 2 pi by omega here? Okay, that is 2 pi upon 3 pi. Okay, and that is 2 by 3. It is again not integer. So is it again aperiodic? Dear, this is again non-integer. This is again going to be not integer. This is again going to be not integer. So is it aperiodic then? Is it aperiodic then? No, here it's still periodic. Sir, why? N cannot be non-integer. If I say this is the value of n, so n is not integer. Okay, but still this is periodic. Why? Remember one thing is that if a value of a signal repeats after n, it will repeat after 2n, 3n, 4n, 5n, etc, etc, etc. Okay, so if the value of the signal repeats at n, I can clearly say that, see, x of n, okay, is x of n plus n, okay, should be x of n plus 2n, should be x of n plus 3n. That is what periodic signal is, na? That is what periodic signal is. Okay, so if the value repeats at n, it will also repeat at 2n. Acha, what is the value of 2n? Okay, now I will not call it as n. I will not call it as n. Now, what is the value of twice of this value? Okay, so when you take twice of this value, this is going to become 4 by 3. Okay, again not an integer. Okay, but when you take thrice of this value, okay, thrice of which value? Thrice of 2 by 3. That's going to become 2, and this time it is integer. So dear, idea is the value is repeating after 2 by 3. So it will repeat after 4 by 3, after 6 by 3. Now that 6 by 3 becomes an integer. So eventually you have a value of the signal which is repeating after 6 by 3 units of time, that is after 2 units of time, which is an integer, and hence this can be taken as period, and the signal is periodic. Okay. Okay, this given signal is periodic. Okay, with what period? With the period n is equal to 2. Okay, which has been obtained as 2 pi by omega into 3. Now, the simple logic is, when I multiply 2 pi by omega into 3, I get an integer. Okay, then why not in the first case I tried this? Because in the first case you have pi, and what is pi? Pi is an irrational number. Suppose if it was 1 by 2. Suppose rather than pi by 2, if it was 1 by 2, I multiply by 2, I get the time period equal to 1. But here it is pi by 2, irrational number. So if any time you have ratio of integers, you multiply by the denominator integer, you will always get an integer. Final answer will be integer, and that can be taken as period. But here, what do you see in the numerator or denominator? Anywhere if pi is there, irrational number, which can never be expressed as the ratio of two integers. I clearly told you last time also, okay, pi equal to 22 by 7 is just an approximation of pi. It is not the perfect value of pi. So don't substitute pi as 22 by 7, okay. So, whenever you have an irrational quantity, whatever integer you multiply, if you multiply by 2, you get pi. Okay, pi is not an integer, it is 3.14. So you can never get an integer here, okay, so that the final time period is integer. Getting it? Okay, so what is the condition? The condition is, okay, the time period sometimes can be 2 pi by omega, like case number 2. It is directly 2 pi by omega. Sometimes, okay, it may not be 2 pi by omega, but it may be twice of 2 pi by omega, thrice of 2 pi by omega, or it may be 2 pi by omega into some integer value. Okay, or sometimes there cannot be any period. The signal is aperiodic. Okay, so the condition for periodicity, dear, will be that the 2 pi by omega should be a rational number. Here 2 pi by omega, 2 by 3, ratio of two integers, I multiplied by the denominator integer, and then I'm finally getting an integral value. That is what I want. Okay, so if this 2 pi by omega is a rational number, then we have a possibility of getting the period. Okay, so what is the final conclusion? The final conclusion is that this a sin omega n or a cos omega n is periodic if there is a condition, if 2 pi by omega is a rational number. It can be expressed as ratio of two integers, correct? And then the fundamental period, 2 pi k by omega, yeah, let me write it like this, 2 pi by omega into k, where k can be any integer. What integer? Logically it should be the integer, okay, which will cancel the denominator. Simple. Okay, where k is the smallest integer so that n becomes integer. Your intention is to make this time period equal to integer, because in discrete domain only integral values of time and time periods are allowed. Only integral values of time and time period are allowed. Okay, this is one difference that you are able to feel from with respect to continuous time domain. Okay, let me write down here and then we will see the next difference. So in continuous time domain, dear, we have seen that a sin omega t or a cos omega t is always periodic with period 2 pi by omega, but in the dt domain, a cos omega n or a sin omega n, a cos omega n or a sin omega n, okay, will be periodic, not always, will be periodic if this 2 pi by omega is rational. Okay, is rational. Okay, and if it is periodic, then the period is given by 2 pi by omega into k. Okay, where k is the smallest integer to make the time period as integral value. Okay, done. This is one of the difference. Okay, this is one of the difference. Okay, then in the continuous time domain, dear, we learned that if you take addition of two periodic signals, x1t plus x2t, yeah, any linear combination, okay, a x1t plus or minus b x2t, okay, where x1 and x2 are periodic, x1 and x2 are periodic. Okay, the signal xt is periodic if the ratio of the time period, so suppose this has the time period t1, this has the time period t2, so the ratio of the time periods t1 by t2 is rational. Okay, and then if this is rational, okay, then xt is periodic, and then the final period t is given by, so t1 by t2 is a rational number, that is n by m form. Okay, that is n by m form, it should be a rational number. Okay, then the final period is given by mt1 or nt2, cross multiply, okay, or okay, basically the LCM of t1 and t2. Okay, that is what we have learned in the continuous time domain, correct? What happens in the discrete time domain? Okay, let us come here. Addition of dt periodic signals. Okay, addition of dt periodic signals. So we have x1n, okay, a signal, okay, periodic with some period that is equal to n1. Okay, we have x2n, that is also periodic, and that is periodic with some period n2. Okay, now I consider, okay, x1n plus x2n, okay, x1n plus x2n. Now last class we clearly derived why that ratio is coming. Just a second. Okay dear, so in the last class we had clearly derived why that ratio is coming. You can refer to the last class, why the t1 upon t2 condition is coming, why it is important. Last class we clearly derived. Okay, so xn is equal to x1n plus x2n. Okay, now same derivation, same logic says that the addition of these two signals will be periodic if n1 by n2 is a rational number. Okay, now here n1 by n2, what is n1 n2? Because it is a discrete domain, what is that important point we have noted till now is n1 and n2 are both integers. The time period can only be integer value. That is what we were learning. The time period should only be integer. That is what we were learning. Okay, so because individually both are periodic and they have some period n1 and n2, okay, and n1 and n2 are automatically integers, so you automatically have ratio of two integers, n1 by n2, okay, is always just a second, it is always and always rational. Okay, always and always rational, and that is why the addition of two discrete time signals is always periodic. Addition of two periodic discrete time signals, no doubt, will always be periodic. There is no condition here. Okay, acha. So if it is periodic, again, okay, let this n1 by n2 be equal to some ratio of two integers like n by m. Okay, then what is the final time period? Final time period, again cross multiply mn1, or it could be written as nn2, or it could again be written as LCM of n1 or n2. That's it. So in the DT domain, addition of two periodic signals xn equal to x1n, okay, plus or minus bx2n, any linear combination, ax1n plus or minus bx2n, where x1 and x2 are periodic. Okay, this is always periodic. No need of ratio test here. Okay, but then what is the final period? Okay, then the final period, again for the final period you have to write down n1 by n2 as the ratio n by m. Okay, and the final time period, as we have just noted, nm1, mn1 or nn2, or LCM of these two, or LCM of n1 and 2. Clear? Or it should be the LCM of n1 and 2. Done hai? Chalo. Next, xn is equal to sine 2 pi by 3n. Chalo. Very simply, let's practice out these cases. Okay, now what is the value of omega here? Sine 2 pi n by 3, sine 2 pi by 3 n, sine omega n, omega is 2 pi by 3. So firstly you have to check 2 pi by omega, 2 pi upon omega, omega is 2 pi by 3, so 2 pi cancel. Okay, it is rational. Okay, and also direct integer. See dear, number one case, if it is direct integer, na, the time period is already obtained. Then it is directly equal to 3 only. Then it is directly equal to 3. Let's have a look into next example. If it is of the form 5 pi by 3n. Okay, so omega here is 5 pi by 3. So what is going to be 2 pi by omega? What is going to be 2 pi by omega? That is going to become 2 3s are 6, 6 by 5, pi cancelled. This is equal to 6 by 5. Okay. This is equal to 6 by 5. Yes, Ashish Mondal, correct answer, that is 3. So here it is 6 by 5. Now this is a ratio of two integers. This is rational. Okay, but not an integer. It is rational but not an integer. But whenever 2 pi by omega is a rational, we know that signal will be periodic. So what is the period? Okay, then what is the period? It is 2 pi by omega into k. Okay, now what should be k? As I told you, k should be the smallest integer. Okay, that can cancel the denominator. Denominator is 5, so take k equal to 5. 5, 10, 15, anything you take, denominator cancels. But I have to take the smallest value for fundamental period. Okay, so just take k equal to 5. Okay, so n will become 6 by 5 into 5. And now it is 6. Again, the idea is same. If the value of the signal repeats at n, it will repeat at 2n, 3n, 4n and also at 5n. So it will repeat at 5n also. Okay, so hence the period here will be 6. The period will not be 6 by 5. Okay, now sometimes in hurry bari you say the period is 6 by 5. That is wrong. In discrete time domain, that is totally wrong. Okay, the first thing is 2 pi by omega. Okay, is it a rational number? Okay, yes. Then we can calculate the period. If 2 pi by omega is irrational, then you cannot calculate the period. So like here, okay, like here, omega equal to 2. So what is 2 pi by omega? What is 2 pi by omega? 2 pi by 2. 2 cancel pi, and pi is irrational. So here 2 pi by omega is irrational. So the given signal, okay, is aperiodic, and hence we cannot calculate any period. Hence we cannot calculate any period. This is definitely aperiodic. This is definitely what? This is definitely aperiodic. Correct. This is definitely aperiodic. Done. Have a look into the next question. A discrete time signal xn equal to sine pi square n, where n is an integer, okay, is 4 options. A simple similar question was there in the GATE 1 mark. Okay, in GATE 2024 also there is a question, a 2 mark MSQ question from this topic. I'll share you that question also. Okay, so here, see, here dear, what is the value of omega? Pi square, the frequency is pi square. So what is the 2 pi by omega? Okay, it is 2 pi by pi square. One of the pi cancel, but still there is a pi in the denominator. It is 2 upon pi, which is irrational, and hence the given signal is not periodic. Answer is D. The correct answer is D. Right? Simple question, 1 mark. Okay. The discrete time signal, okay, xn cos pi n by 9 plus sine pi n by 7 plus half. Okay, this signal is what? Options A, B, C, D. This signal is equal to what? Options A, B, C, D. Okay, so first you have to, check individually whether the signals are periodic or not. Okay, here what is the value of omega? Pi by 7. So what is 2 pi by omega? 2 pi by 7. Pi cancel, 2 7s are 14. Okay, rational, and not only rational, it is direct integer. Okay, so the period itself is 14. Then we don't need any k value. Okay, period is 14, n2, that is n2. Okay, this is the first signal. What is the value of omega? Okay, is pi by 9. So directly let me write down what is 2 pi by omega. that is 2 pi upon pi by 9. That is pi cancel 18. Again direct integer. So that is the period itself. So what is the value of n1 is 18. Okay, and if two discrete time periodic signals are added, then the result is always periodic. If individually they are periodic, then there is no other test required. Okay, it is always periodic. It will not be aperiodic. But with how much period? So now n1 by n2 is 18 by 14. I clearly explained, why it is always periodic, because the logic was telling you that the ratio of the time period should be rational. That's what we derived for continuous time domain. Okay, so here if you take the ratio of time periods, both of them are individually integer. So always the ratio will be integer to integer. That is rational number. Okay, so that is why it is confirmed periodic. Okay, now write down in the simplest form, this is 9 by 7. Okay, so what is the final time period? Same technique, cross multiply 7n1 or 9n2. Any one calculation you can choose. Okay, the 7 into n1, what was the n1? 18. Okay, 7 into 18, it should be how much? It should be equal to 126. It should be the 126, correct? So this one is periodic with the period of 126. Option number A correct. Okay? Option number A. This one is definitely periodic. Any confusion, you can please ask me. It is periodic with period 126. Okay, with the period 126. Done. Chalo. Just a second, let me also take that question. I think I have it with me. I think that's not there in the PPT. Just checked. Again, check it. Yeah, that is not there. So yeah, I have it in the mobile. No worries. Okay. So current year, GATE 2024, MSQ question, multiple select question, one or more options can be correct. Okay, so you are given a discrete time signal. A cos of omega n plus pi by 3. A cos omega n plus pi by 3. Okay. What is the value of omega? Okay, for a period of 40. Okay, for a period of 40. So that the signal has a period equal to how much? Equal to the 40. Yes. What can be the value of omega? Acha, MSQ question hai, so let me write down the option also for you. Okay, option number A 0.15 pi. Option number B, okay, 0.45 pi. Option number C, okay, 0.3 pi. Option number D, 0.225 pi. Okay, these are the four options given to you. Correct, dear? Ashish, this was an EC this year, 2024. Okay. So discrete time periodic signals questions ECEE दोनों में आता है. Chalo guys, let's get started. Now what can be the possible value of omega? MSQ question hai. Okay, there can be multiple options correct. Okay, so that the given signal is periodic and that too having the period of 40. Okay, so now dear, if I test option number A, okay, if I go with option number A, okay, option number A mein what is the omega given is 0.15 pi. Okay, so first of all, what is 2 pi by omega? See, all options actually are having pi. So when you divide 2 pi by omega, all options have pi, so pi cancel. Okay, so there will be rational. There will be the rational case coming up. So Raju says the answer as ABC. So there is one answer coming up. Let's take it. Come on, everybody be active and solve. Okay, so 2 pi by omega, pi cancel. This is 2 divided by 0.15, or you can further cancel it like 200 by 15, or smallest ratio के form में लिखेंगे. So it is 40 divided by 3 cancelled with 5. Okay, it is 40 by 3. Okay, now whether it is rational, yes. I told you, all options have pi, so definitely 2 pi and that pi will get cancelled. Okay, so it is rational, but the answer is not integer. Okay, answer is not integer, so we cannot say the period is 40 by 3. So what is the period? As I told you, it should be 2 pi by omega into k, okay, where you can choose k equal to 3. The smallest k is 3, that will cancel, and the value of n will be equal to the 40. The value of n is equal to the 40. Done, eh? Okay, cool. Next, omega is next option, 0.45. So A तो correct है. Okay, A तो correct है. 0.15 was done. Next option is 0.45 pi. Okay, now what is 2 pi by omega? That is 2 pi upon 0.45 pi. Okay, so that is 2 upon 0.45. Again, that can be written as 200 by 45. Cancel with 5 again. It is 40 divided by 9. Okay, now it is rational. Yes. So there is no problem. It is periodic. This is rational. Okay, but what is the final time period? It is 2 pi by omega into k. Okay, where k should be? Okay, where k you can choose it as 9. K you can choose it as 9 and time period again looks like 40. Okay, time period is again 40. Okay. Chalo, Ashish Mondal also comes up with the answer ABC. Great. Great, great, great. Now let's go to the C. Okay, let's go to the C. Because MSQ you have to check all options, dear. You have to check all options. The next is 0.3 pi. So first of all, dear, what is 2 pi by omega? That is 2 pi upon 0.3 pi. So this is 2 upon 0.3 or simply 20 by 3. Simply 20 by 3. Okay. Is it rational? Yes, still it is rational. Okay, but it is not integer. The period is not 20 by 3. So period can be 20 by 3 into k. Okay, where k I can choose at 3 and the period, fundamental period is 20. Okay. Okay, Dinesh, noted. Okay. Now this is 20. This is fundamental period 20. Question says what? What is the fundamental frequency for a period of 40? See, there should be a period of 40. And I clearly told you, if period is 20, okay, if the signal value repeats after n, it repeats at 2n, it repeats at 3n, it repeats at 4n, it repeats till infinity. Right? So, definitely here period can be 40 because the question did not say fundamental period. The question did not say fundamental period. They are only telling period. So, this also is a correct option. Dear, this also is a correct option. Okay, and the last option that is coming up is 0.225 pi, 0.225 pi, and now if I check 2 pi by omega, that is 2 pi upon 0.225 pi, pi cancel, and then, if it can be written as 2000 by 225, cancel with 25, so this is 9, and this is 880, this is 80 by 9, again rational but not directly a integer. Okay, so what can be the time period? It could be such that 80 by 9 into k. Now I can choose k equal to 9 and the period is 80. The fundamental period is 80. Now if the fundamental period is 80, what are all the values, possible values of the period? What are all the possible values of the period? Okay, it could be 80, it could be 160, okay, it could be what, 240, but can it be 40? No, it cannot be n by 2, it can be n, 2, n, 3n. So here 40 period is not possible. Here the 40 period is not possible. Okay, now this question, interestingly, 2024, as I told you, MSQ question. Okay, this was original answer given by IISc was A and B. Okay, but then students challenged, and that was a very valid challenge. The actual first answer key that came up was only having A and B. But then the students challenge, your question says only period. If it says fundamental period, then A and B are correct. Because in A and B, we got fundamental period as 40. C mein the fundamental period is 20. But question did not say fundamental period. Okay. And period means any value of time after repetition occurs. If the repetition is after 20, it will be there after 40 also. That is also period. Okay, this was a very valid argument given by students. Okay, I also spoke about this earlier in the YouTube, and the challenge was accepted, and then the corrected answer key, okay, that was given was actually AB, okay, or ABC. I mean, if you are a student, okay, they did not say ABC only as the final corrected answer key. What they told, if you are a student, if you have marked AB taking fundamental period, you are also not wrong, because most of the times period by default means fundamental period. So you also get 2 marks. Okay. If you are a student and you have selected ABC correct, okay, so you also will get the correct marks because you have taken the basic meaning of period, not the fundamental period, but you are also correct. If you have chosen D, then that is something wrong. Okay, but whether you have chosen AB or ABC, both were given correct marks. Okay, it's not like those who chose AB, they were given incorrect marks. No. Okay, so that is what happened in this current year only. GATE 2024 MSQ 2 marks. Chalo, done. Let's move ahead to the next then. Okay, if this is clear, let's move ahead to the next. I hope the question is clear. Okay, guys. Okay, so you know, last class, I gave you homework actually with continuous time, and I told you to try for discrete time also. I actually gave the question on continuous time because last class we were discussing continuous time. Okay, the signal of the form sine of t square, sine t is periodic, sine of t square. Okay, yeah, sine of n square, will it be periodic? Will it be periodic? Dekho dear, the simple logic is, okay, here sine of n square is coming. Okay, here sine of n square is coming. Dekhte hain. Okay. If a signal is periodic, see, it is not sine n or sine omega n where I can apply my previous knowledge. The signal itself is different. Sine of n square. Okay. If it is periodic, it should satisfy x of n plus n equal to x of n. That means sine of n plus n, okay, whole square should be sine of n square. Okay. Now, let me expand this. Sine of n square plus capital N square plus 2nn should be equal to sine of n square. Now, will this be true or not? Will this be true or not? Dekho, this is possible. This is possible if this additional term sine theta, this is theta. Suppose this is theta, this is theta. Okay, so sine theta repeats after 2 pi. Okay, sine theta plus 2 pi, they are equal. Okay, they are equal. Okay, they are equal. Okay, so now n square plus 2nn, okay, it should be equal to 2 pi. Now dekho, this is integer, n is an integer, this small n is also an integer, this capital N is also an integer. Okay, dear, whatever you have in front of you is everything integer. They are multiplied and they're squared, they are added. The final result has to be integer only. Final result has to be integer only. Good evening, GATE. The final result has to be integer. Okay, so this concludes that n square plus 2nn will also be an integer. Okay, and hence not equal to 2 pi, because 2 pi is not an integer, na? And hence 2 pi is not an integer. So whatever value of the time period, you can try with the value also, period 1 ya period u2 ya period 4, whatever. Okay, I did not try any value because normally we can see in a capital N, small n, both are integer, because in discrete domain any value of time fitted inside the function should be integer. Okay, so the left hand side overall is integer and we need to make it to 2 pi, and 2 pi is not integer. Hence this is not possible. Hence this is not possible. Okay, so the given signal is aperiodic. The given signal is aperiodic. Okay, dear? Okay, good question this is. And by the same logic, okay, I'll give the answer for continuous time. Let's today discuss discrete time. Same logic, same argument, you will get that this option number D is also not periodic. Okay, because here what you are going to get? Here you are going to get t square plus 2tt. Okay, should be equal to 2 pi. Okay, maybe for some values of time, but is it equal to always? Okay, is it equal to 2 pi? Not always. So hence this signal is not periodic. Here integer condition is not coming up. in continuous time domain, the time period and the time can take any value. Okay, maybe under one calculation, under one particular calculation, this becomes 2 pi. Maybe under one particular calculation, it becomes 2 pi, but not always, na? But not always. Okay, ठीक है. आशीष, नो इट वेरीज ईयर टू ईयर. अगर आपको चाहिए कि कितने नंबर आते हैं, सो यू नो लास्ट वीक आई हैव टेकन अ सेशन, द कंप्लीट वेटेज एनालिसिस ऑफ सिग्नल एंड सिस्टम, सिलेबस, वेटेज एनालिसिस, बेस्ट बुक्स. सो यू कैन जस्ट वॉच सेम चैनल, ओम इंस्टीट्यूट यूट्यूब चैनल. ओके, ऑन द सेम ओम इंस्टीट्यूट यूट्यूब चैनल आई हैव टेकन अ वीडियो लास्ट वीक. आप उसको देख सकते हैं. ओके, सो यू गेट द कंप्लीट इन्फॉर्मेशन अबाउट सिग्नल एंड सिस्टम एंड द वेटेज. ओके, नाउ डियर, देयर इज अ चेंज इन द क्वेश्चन. ओके, साइन ऑफ पाई बाई 2 n square. Sine of pi by 2 n square. Again, I will apply the same logic. X of n plus n should be xn for periodicity. Okay, for periodicity. So sine of pi by 2 n plus n whole square equal to sine of pi by 2 n square. Will this be periodic? Will this be periodic? Okay. Sine of, okay, let me open up the bracket, pi by 2 n square, then pi by 2 capital N square, then pi by 2 2ab, so 2nn. Okay, this should be equal to sine of pi by 2 n square. Now this basically means that, okay, this term, okay, if this is theta, sine theta plus 2 pi you should be getting. Okay, so this should correspond to 2 pi. Okay, this should correspond to 2 pi. So this can be periodic if pi by 2 n square plus here 2 cancelled plus pi nn equal to 2 pi. Not necessarily 2 pi, any multiple of 2 pi. The value of the signal can repeat at 2 pi. Okay, the value of sine theta repeats at 2 pi. So it repeats at 4 pi also. It repeats at 6 pi also. So it can be 2 pi. Okay, or any multiple of 2 pi, 2 pi k. It can be any multiple of 2 pi, 4 pi, 6 pi, anything can be taken. Okay. Now, whether this is possible, see, definitely there is a hope here. Definitely there is a hope here. Okay, because left hand side also pi, right hand side also pi. Chalo, let me cancel out the pi. Let me cancel out the pi. So I have, let me take n common. Yeah, ठीक है, n को as it is रख देते हैं. Okay, n square by 2 plus pi is cancelled plus nn is equal to 2 or 2k. Okay, should be 2 or a multiple of 2. Okay, can it be possible? Can it be possible? Can it be possible? Now let's take option number A. Okay, okay, it can be possible. Let's assume, okay, time period n equal to 1. Let's assume time period is 1. Okay, so 1 by 2, okay, n square by 2 plus n. Okay, can it be 2k? Can it be a multiple of 2? Dekho, now you have n plus half. Can it be equal to a multiple of 2? Now multiple of 2 means 2, 4, 6, etc. Okay, n plus half is coming na. N is integer plus half, so answer will be like 1.5, 2.5. Okay, so this answer may be like n can be 0, n can be 1, this can be maybe 1.5, maybe 2.5, etc. Okay, so definitely this is not the correct answer. Option number B. Try n equal to 2. Try n equal to 2. So n square by 2. Okay, plus n into capital N. Okay, this should be 2k. Okay, 2 square by 2, that is 4. 4 by 2 is directly 2 plus 2n. Now what is the value of 2 plus 2n? Now what is the value of 2 plus 2n? N can be any integer. Now suppose I take 0. Okay, so 2 plus 0. Okay, then this is n equal to 1, so 2 plus 2, 4. N equal to 2, so 2 to the 4 plus 2, 6. Okay, then next value 8, etc, etc, etc. Perfect. This is definitely equal to 2k. This is definitely what you want. Okay, so B is the correct answer. Okay, and hence B, options are shuffled here. This should be B, this should be C, and my correct answer is B. Okay, let's only focus on the fundamental period. Okay, because if the period is 2, then option number C will also satisfy. So again, okay, if I make it as a MSQ question and only tell you to ask period, then B and C are both correct. But I am only asking fundamental period. Okay, I am only asking fundamental period. Okay, and that is equal to 2. Clear? So sin pi by 2 n square can be periodic. Sin pi by 2 n square can be periodic. Okay? Sin pi by 2 n square can be periodic. Okay, but if it is again pi by 2 t square, it will be not periodic. It will be not periodic. T square by 2 plus 2tt should always be 2k. Okay, should always be 2k. Okay, and yahan pe if I try t equal to 2, okay, so 2 square by 2, 2, okay, plus, okay, plus it was only tt. Same calculation I am repeating and explaining you quickly. Okay, and now plus 2t should be 2k. Okay, in the discrete time domain, time can only take integral values of time. But here this t can take any value. This t can take any real value, not only integer. Okay, so that means 2 plus 2t, okay, is equal to 2k, maybe, but not always. Okay, it will again be equal if you take t as integer. Okay, but not always, because t can take any real value. Okay, so this is not always true, and hence this signal is not periodic. Hence this is what is not going to be periodic. Clear, everybody? This is what is not going to be periodic. All right. Okay, so some different and good questions also you should adapt in your learnings. All right, guys, so an important update for all of you, that if you are a GATE ESE aspirant, okay, and waiting to prepare completely for GATE 25 or GATE 26, okay, at your own comfort through the online live batch. So June 1st, yes, the next 2 to 3 days, the new batch, online live batch for ESE is starting. Now this course will have complete concepts required to crack the GATE examination and all the best problem solving approach, and more than 3000 problems to be discussed within the live class. Okay, you get daily lecture notes, topic wise handouts, so that for you have self practice also after the class, topic wise PYQs with the solutions. Okay, and doubt solving sessions also keep happening, and you can access it anywhere, okay, from your mobile, laptop, tablet, anywhere. Okay, you can watch it from our app or you can watch it on our website. Okay, so yes, the multiple features you get. Okay, the fees, okay, is 29,999 for GATE 25, but currently it is 19,999, and similarly for GATE 26, currently the fees is 28,999. Okay, similarly guys, with all similar features, exactly same what I told you, okay, with the same fees also. Okay, the new batch for GATE EE, online new live batch for GATE EE starts 4th June. Okay, that starts 4th of June. All right, that starts 4th of June. All right, guys, and also, okay, the next offline regular batch. Okay, the next offline regular batch. Okay, so if you are willing for the complete offline preparation in front of the faculty, dedicated sitting, okay, and preparing under the faculty guidance, so that's going to start from the next that is 30th of May with the fees, okay, 66,000, but currently it is 56,000. And also there are several benefits, like if you are from IIT or NIT, the flat 50% scholarship. Okay, if you are a previous OHM Institute student only, then also you get flat 50%. Okay, if you're IIIT or any other state government college student, 30%. So several scholarships are there for you. So if if you're in Hyderabad, or if you're planning to come to Hyderabad to study offline, because many students are adapting to it again, yes, you can have the offline course as well, and everything, study material, test series, everything will be included within it. Okay, you get the printed study material and each and everything here, right? For any more queries about the batches, whether offline batch, online batch, anything of your comfort, whatever you feel like, okay, any queries you have, you can just contact 95156940053 or visit our website www.ohminstitute.com. Okay. It is decent, Ashish. Not the best, but it is good. Okay. You cannot compare it to, for EC students, like it will not have that VLSI type scope, but it is a good option, decent option, Ashish. ठीक है जी, चलो. Okay guys, so this is Rakesh Sir signing off for today. Bye bye, good night, thank you, stay safe and do take care of yourself.